So, got it. And I just need the thing to kick over. And then I think I gotta pause it here. Okay. So, got it. Okay. So let me see. So let's kind of hang out here for the moment. So one thing is, I do live stream my sessions. I finally figured out the nuances and how to get it to work properly. I do live stream our interactions to my YouTube channel. So again, it is important, at least while you're my student, to go ahead and be subscribed to my YouTube channel with your notifications turned on. I know it sounds like a shameless plug because it is a shameless plug. No, ain't no shame in the game. But and that's my business, like Tabitha Brown. I don't know if any of y'all follow Tabitha Brown, but she's hilarious. And she's just gives a lot of uplifting, constructive information. But I do stream these on YouTube Live. So, and I try to be cognizant of not sharing you guys sensitive information, as far as names and things, as best I can. So that's the first thing. I just wanted you to be aware. I am streaming these live on my YouTube channel. And again, I do want to encourage you to go ahead and be subscribed to my channel with your notifications turned on. And that's actually very important because, for instance, once I start responding to homework questions and inquiries, and I start just anytime I post a video or go live, you at least want to get a notification so you can be aware about what I'm talking about. Because inevitably, you all will have similar questions, and at least if you know there's a video on my channel that directly relates to what your question is, then I don't have to be too repetitive, and you can at least, it's just about awareness. And then once the semester's over, you're welcome to still be subscribed, but you can just turn your notifications off. That way you're not being bombarded by the videos that I post until I start because actually I do intend to kind of post 2 other types of topics as well, as far as metaphysics and gaming. Those are other things that I just really enjoy. And at some point I'll start to share some of that stuff, but I'm not there yet. But for right now, I'm just using it as a platform for mathematics. So that's one thing. Let me see if there was something else. Let me see for a moment. Yeah, I hope everyone enjoyed their holiday, their King holiday. You were able to do what you needed to do. And so for today, let me kind of do something similar with you all, what I do with my earlier students. And my little dog is, I'm going to share a post. I think we did something similar to this before. I just created a poll, and we can do one of 2 things today. The section is section 2.5 over rational functions. So we can either just dive into the homework and get through as many homework questions as we can, or we can go through the lecture corresponding to section 2.5. Keep in mind, this lecture is already recorded on my YouTube. It's a little bit long. It's 2.5 hours. So you just have to pace yourself. It is a lot of information, and I do expect you to go through it on your own. But it seems like as I look at these numbers kind of dance, more people would like to go through the homework, which I think that's the move I would recommend as well. I'm just going to leave that poll open. Yeah, that's cool. So I did get a direct message. I'm pretty sure you guys can see it. That somebody's ahead on the homework, and that's what I actually encourage. I'm glad he mentioned that. I do encourage each person to go ahead and get ahead. The idea is that I've already posted all the homework and the quizzes for the semester. So if you go ahead and complete all that homework and get it to whatever grade you want it to be, and get those quizzes to whatever grade you want them to be, the only thing you're going to be waiting for on my end, you're going to be waiting for the exams. So once you complete all those assignments, just check in at each session just to get your attendance credit. And then just be sure to complete your exams when they come out on time. And, that'll free up time in the future. When the midterms hit, you won't be bombarded. At least that's one class that you know that, okay, I don't have a whole bunch of work I need to do there. I can focus on my other things. Or when we get to the finals, it's just going to be the exams that you won't have to be trying to play catch up with all these assignments, which, you definitely do not want to be playing catch up with these assignments, because inevitably what happens is when we get closer to the end of the semester, for some reason, the Pearson servers just shut down and they become totally unreliable. It just seems like I guess everybody nationwide is trying to use it all at the same time. So again, long story short, I definitely encourage everybody to get ahead. Okay, I can't think of anything else that's pertinent. If you have any questions or anything, just, you should be able to unmute yourself and just chime in, stop me. I can kind of talk a little fast, and not my resentment speed. That's not where I'm trying to go. Right. Okay. So again, most people in the class did say that we'd like to go through the homework. So we're going to get through as many of these homework questions as we can. So this is from week 2, section 2.5. And again, because we're doing a remote asynchronous, if you have questions from other sections, pardon?
What's your YouTube channel? I asked in the chat, but I didn't get a response.
The YouTube is Beautiful Mind. There's a link on our Black.
You cut out. What'd you say? Where's my Wi-Fi?
Can anybody hear him?
I think you're muted.
Yeah, I can't hear him either.
Unmute. Let's see. Okay, it seems like we're back. It looks like we're live. I'm gonna just kind of let that be for now. Has started screen sharing. Let me just try one more time. Screen. Start. Let's stop other screen sharing. You want to continue? Yes. Okay. So I'm gonna let that be for now. I'm gonna hop back to the question that we were working on. I think it's okay. Right. So again, there was no value of W that was going to make the denominator 0. So we didn't throw out any value. So the domain here was all reals. So I'm going to just kind of let that be. Next question. All right. So this one, we're asked to find the domain. So again, in general, the domain of a rational function is all reals except any x that make the denominator 0. So we need to find what values of x makes the denominator 0. I'll do that later. Okay, so let's. I'm going to take some notes on this one. So let me get a copy, and I want basically from here. This is what I want. Okay, and then from here, you can drop it right there, boom, just like that. Okay. So we're asked to find the domain of the rational function. So again, long story short, we're trying to find what values of x make the denominator 0 so we can exclude those values. So what we're going to do is we're going to set the denominator, we're going to set it equal to 0. So then that's going to be our x squared plus 2x minus 24. We're going to set that equal. Set that equal to 0. Okay. So then because this is college algebra 2, we expect you to be comfortable with factoring, right? I do acknowledge that most students are not comfortable with factoring. If you would like more practice on factoring, I actually loaded an entire chapter devoted to pretty much all the factoring scenarios we're going to come across in this course. It's on our Blackboard page, and if you go to that folder number 3, wherever it says the box link, and then there you're going to find a folder that says handouts. So if you want more practice on factoring, there's a chapter in the box link, and you can sit down with the tutors or me, and you can work through that entire chapter, and it'll go through all the scenarios that you'll come across and you do some practice. So now this is factoring a trinomial, right? So something we want to try to factor it in some form of like this and this. Can someone tell me about the signs? Like, should our signs both be like plus and plus or plus minus, or can someone tell me about the signs here? Like, anybody tell me about the signs?
1 plus 1 minus.
What makes you say 1 plus or 1 minus? Why do you say that?
Because the second term is positive.
Yeah.
So that means that, well, negative, you're right, negative. So it'll be multiplied together and then positive plus.
What you're saying?
Say it again.
Yes, that's exactly it, right? So when we're going to factor a trinomial, again, this is a trinomial because we have 3 terms, 1, 2, 3, right? So because this second sign is negative, when we go to multiply them, a positive times a negative gives us a negative, right? So that's why. So because the second sign was negative, that's why we had opposite signs. If the second sign were plus, these 2 signs would be the same, right? It would be the same. So the second sign being negative tells us they're opposite. This first sign tells us the sign of the larger number, right? So this means the larger number is going to be positive. Okay, so then we need 2 numbers that multiply to give us negative 24 and add to give us 2. Anybody got those numbers?
Six and 4.
6 and 4, right? Notice that 6 times negative 4 is negative 24. 6 plus negative 4 is a positive 2, right? So then at this stage, we use a technique called the 0 factor property. Basically, when 2 or more things multiply to give us 0, then basically we set each thing to solve. because if this first thing equals 0, if the first thing is 0, then the whole thing collapses to 0, because 0 times anything is 0. If the second thing is 0, the whole thing collapses to 0 because 0 times anything is 0, right? So what we do, we basically set each thing to 0 and solve. It's called the zero factor property. So we have x plus 6 equals 0, or x minus 4, that's not a minus, x minus 4 equals 0. If we solve, x equals -6, or x equals 4. Right? So what we're saying is that the domain of this rational function is going to be everything except -6 and 4, right? So this is called, we call this our set notation. Set notation. Okay. And again, here we use the zero factor property. Okay. So now we want everything except these two. Let me go ahead and identify this. We want to throw out the -6. We want to throw out the 4, right? So what we're going to do, we're going to just plot these on a number line. Okay. Let me try that again. There it is. Okay. Let's see, the far left is -6. And then here we have the 4, right? So we want to throw out everything except these two. So basically what we're saying, we want every number to the left of -6. We want every number between the -6 and the 4. We want every number to the right of 4. And if we don't want the -6 and 4, can somebody tell me, do we use parentheses or do we use square brackets?
Parentheses.
Parentheses, right? So parentheses means we get close to that number, but we don't include it. We get close, but we don't include it. And this basically, this is like the graph. This kind of primes us for the interval notation. Again, this is the graph. And then in the interval notation, you don't have to do all of this, and just give them backstory. So this makes it easy to see the interval notation. So the far left is -infinity up to -6. And then we want all the numbers from -6 to 4. And then we want all the numbers from 4 to infinity. Right? Infinity always gets a parentheses, right? Because we never reach it. In this context, the -6s and the 4s get parentheses because we get really close to those numbers, but we also don't ever reach, we don't include those numbers. And then we combine these three sets. This is called union. It's called union. Right? So basically it's saying like it can be any number in that first interval, or it could be any number in the second set, or it could be any number in the third, all right? Okay. So now with that, we can hop back here. And I think we got part A. Yeah, let's go with that. Okay, and again, just stop me if anything isn't clear. We can go back if you're mute or mum. I don't know about the mum part, but you know, otherwise I'm just gonna kind of keep moving forward. Okay, next question. Let me see the time. And we only got, I don't want to keep you more than 15 more minutes, right? So in this example, we're asked to use the graph of the rational function to complete the following statement. As x approaches 2 from the right, our y value approaches what, right? So let's get a copy of this. And what I would like to do, I just want to use this image. Come on. So just to get a little bit interactive. Right. I don't know why my dog likes to do that. She loves to, like, anything that she sees moving, she just is like, how dare you? How dare you exist? Is how she acts. Like, how dare you get in my field of vision? You don't have the right to be in my field of vision. That's how she acts. It's so funny to me. Now, as x approaches, I think we said 3. Let me go back. I gotta look at it. this. So as x approaches 2 from the right, what does our y value do, right? So we see our 2 here. I'm going to identify it with a red dashed line. So like that style, like this. Let's go here, here. That's good, right? So I highlighted the as x equals 2 with a dash vertical line. Now, as we approach this coming from the right, where is my tool? Am I not sharing? Let me see. What? You need to reboot the device. We cannot restart. Share the screen. Screen. Start broadcast. Yeah, I don't know what's going on with technology today. It is just like on the issue. Okay, hopefully you guys can see my screen now. All right, so it says as x approaches 2 coming from the right, right? So I highlighted the 2 with a red dash line. As we approach 2 coming from the right, notice our y value goes down to negative infinity. It goes way, way down, right? So then, it's not. Come on. So as x approaches 2 from the right, y tends to negative infinity. Negative infinity. Okay, let's go with that. I'm going to go on to the next one. Again, stop me if anything isn't clear. I'm going to try to piggyback off of what we just did, right? So as x approaches -4 coming from the right. So let's look at this image. So -4, you see it on is the left dash arrow. As we approach -4 coming from the right-hand side, our y value goes to negative infinity. Y goes to negative infinity, right? Oops. So right here. And if that's not clear, just stop me and we can talk about it. Otherwise, I'll just keep moving. Okay, let's go on to the next one. As x goes to infinity, what happens to our y value? All right. So as x goes to infinity, so that's to the far right of the screen. As x goes up to the far right, y approaches the x-axis. In other words, y tends to 0. Come on. I think it's me like expanding it. Might be there it is. Y tends to 0. So as x goes up to the far right, y gets closer and closer to 0. Okay. What are the vertical asymptotes, right? So look at this graph on the right. We got, oh man, battery's getting low. As we look at this graph on the right, the vertical asymptotes occur when x is what? 5 and -5. So we got x equals -5, comma, x equals 5. Okay. Describe how the graph of this can be obtained through transformations of 1/x. So now we have this 1/x minus 5, where the parent function is the reciprocal function 1/x. So the only change that we did, we put that -5 inside the parent function, right? So if the parent function is g of x equals 1/x, then to get to f, we did g of x minus 5, right? That -5 is inside the parent function. So if we subtract a positive inside our parent function, that's going to cause a horizontal change, and it should shift it to the right by 5 units. So that's kind of like a review or recap of transformations from college algebra 1. Let me see. So it's either B or D. Let me see. No, it's not B because that's no, that's not right. It's neither of those. Shifted right by 5 units, right? So the only one that went right by 5 is C. Right? So we went right by 5 units. So we're going to go with C and check the answer. Okay. And then the vertical asymptote. Oh, so the vertical asymptote is going to occur. Asymptote. I think it's asymptote. The vertical asymptote is going to occur when we find any x value that's going to give us some number over 0, right? If it gave us 0 over 0, that's not going to appear as a vertical asymptote. That's going to appear as a hole in the graph. But as long as we get, when we plug in that x value, if we get some number over 0, that's going to be a vertical asymptote. So in this case, notice if we plug in x equals 5, that's going to give us 1 over 0. So that's going to be, so that means that vertical asymptote occurs when x is equal to 5. So you just have to kind of be on the lookout for any x. If it gives you 0 over 0, then that's not a vertical asymptote. So now, hopefully you've seen the lecture for this. In that lecture, we kind of mentioned something about there's a three-prong test to determine the horizontal asymptote, and it's all kind of centered around the degree of the numerator versus the degree of the denominator. So for the horizontal asymptote, in this case, the degree of the numerator is 0, and the degree of the denominator is 1. So because the degree of the numerator is less than the degree of the denominator, then our horizontal asymptote is going to be y equals 0. Right? Y equals 0. So again, I go through those details in the lecture. There's a three-tier test for the horizontal asymptote. So we had a vertical asymptote. Damn, now I'm stuck. Is it asymptote or asymptote? I think it's asymptote. So we said the vertical asymptote was x equals 5, and we had a horizontal asymptote of y equals 0. So then it has to be either A or B, right? So then we just need to be in the proper region. So for instance, say when x is 8, do we get a positive result or a negative result, right? So if we plug x equals 8 in, notice we get a positive result. So when x is 8, we should be in the positive side. So then it should be B, right? Because I think A, when x is 8, it has a negative result. So I just kind of verified a few points. All right, so I'm going to go with B. Okay, again, if anything isn't clear, you have to stop me and we can go back. Otherwise, I'm just going to kind of power through. Oh, we only got like 5 minutes remaining, so we're going to go, I don't want to call it sudden death, but we're going to do a speed round. See how many questions can we get through in 5 minutes, right? Because that's how long I want to keep it. So describe how the graph of the given function can be obtained through transformations of the reciprocal function, right? Okay, I think we need to rewrite this one. Let me think about it. We could simplify it. Let me think about it. If I start with 1 over x, I can put the minus 2 on the inside. That'll be there. I feel like we need to do polynomial long division. I'm gonna call it an audible, and I'm actually gonna So I'm gonna use this get more help. So because of this get more help is the reason why I kind of push Pearson. It's a very useful tool. I don't really recommend to help me solve this. That was okay, but the viewing example. Just about every question has the viewing example, and what it does, it gives you the exact same question with different numbers, and it also gives you an explanation behind the reasoning of the question, right? A lot of the questions have the video tutorials and have the digital ebook, and then you also have the Ask My Instructor. When you use the Ask My Instructor tool, it'll basically open up an email prompt. And when you send me the email, it'll send me a screenshot of the very question you're working on. I'll load it. I can load it to my tablet, make a dedicated YouTube video responding to that question, and then send you the link, when I post it to my YouTube, right? So I'm going to click on the view an example. And I want to say that we just go ahead and do the long division here, but I want to see what they do. So it's a total of 4 parts. Yeah, they're just doing long division. Let's just go ahead and do long division. I can take it from there. So I'm going to get a copy of this guy. Hopefully my screen doesn't crash. I thought we were going to be able to get through these a lot faster, but that totally did not work. Nope, not there. Let's go here. Like a copy of this? Come on. There we go. Yeah. And then I just wanted to get this one. Yeah, it's fine. There, here, here. I just wanted to copy here. We can drop it right there. All right, so let's do. I think I personally I'd rather do synthetic division because we can do synthetic division. We don't always have that luxury, but whenever possible, I feel like it's easier, right? So we just need to do the polynomial long division, but I'm going to do synthetic division. Damn it, my screen, my screen I keep dropping my screen. I'm assuming, I think we're still broadcasting, so. So now the reason we can do synthetic division is because we're divided by a linear binomial, right? So if we're going to do synthetic division here, we would do a 2 in the chair, and then we just need the coefficients, right? So then we would need the 3 and the -5, right? So then when we're doing synthetic division, the first one just comes down, and then on the diagonal we multiply. So 2 times 3 is 6. And then 6 plus -5 is 1, so that's our remainder, right? Okay. So then this should be equal to, am I doing this right? It should be equal to 3 plus 1 over x minus 2, right? So I'm just going to call that f of x. Or, well, instead of doing that, but the main thing that I really want to do, I have x minus 2, 1, and then I just wanted to rearrange it, right? So now in this form, now we're ready to talk about transformations, right? So say f of x, was our parent function in the form of 1 over x. Then if we want to get to g, so I'll just do it. So g of x is going to be, now, if we're starting with 1 over x, first thing is we can do that -2 inside our parent function. So we're going to say f of x minus 2, right? We put that -2 inside. Then we added a +3 on the outside of our parent function, right? So now if we want g of x, that's going to be f of x minus 2 plus 3. So those are the 2 transformations that we did. Let's submit this, see how do we do, and then we'll kind of close out, right? So the 2 transformations that we got, basically that -2 on the inside tells us that we're going to the right by 2 and then up by 3, okay? Right, 2 and up 3, right? And that's not readily obvious from the original way that it was given. Let me see. Yeah, let's go with it and let's see what happens. It's gonna go here. We're gonna give it a go. Now, first it says choose the horizontal transformation. We say right, so 2 units to the right. Kind of close you out. 2 units to the right. I'm gonna hit enter. And then the vertical. We said 2 units right and up by 3, right? And again, the way it was given originally, so let's just do a quick recap. Because if we didn't do that long division, we wouldn't have gotten that, right? Because it's not obvious from the way it was given. But then once you do the polynomial long division, you rewrite it, right? We got this solution in the upper right-hand corner here. We got this guy, and then we just switch the position and we finished here. So then this tells us we went right 2 and up 3, right? That's where that came from. And again, we can write g in terms of the parent function of this, and that makes it even more clear. Okay. So we finished that question. This is the time that I did want to stop to let you all out. I know that there was a request towards the beginning of the class, so hopefully the student is here. We can straighten that out. If there aren't any other questions, I'm actually going to end the stream here. And from one beautiful mind to another, I want you to enjoy the rest of your day. You guys have any questions before I go? Okay, let me go ahead and end the stream.